Hi guys, welcome to Learn Tech from Zero. Today I'll be covering further CCNA topics, so let's begin with today's topic, which is configure and verify IPv4 addressing and subnetting. In this video, I will not be converting binary to IPv4 addresses and IPv4 addresses to binary. This is something that if you are new to converting binaries to IPv4 and etc., you need to learn a lot. So basically I will need to provide a separate guide which will be about 1 hour long, and I aim to upload the video in the coming week. So if you're interested, then you can go on YouTube and subscribe, and when I upload that video, you will get a notification. So today I will be just giving you a quick overview of this topic. So what is an IPv4? IPv4, Internet Protocol version 4, is a network layer protocol, layer 3 of the OSI model, that provides logical addresses for devices on a network. It allows devices to send and receive packets across interconnected networks, LAN, WAN, Internet. In simple terms, IPv4 is a layer 3 network layer protocol in the OSI model. This is the protocol that the routers have to follow. Okay, this is the protocol a layer 3 switch has to follow. So with IPv4 addresses, devices can communicate within external networks. So you need IPv4 addresses if you want to access internet. For accessing, let's say when devices communicate with each other in a local area network, LAN, they don't need to, unless they are not in separate VLAN, they don't need to communicate through IPv4 addresses. If they're in the same VLAN or if in the same network, the devices can communicate with MAC addresses, and if they are in the separate VLAN, then they need to communicate through IP addresses, or if the devices need to communicate to external networks, then they need to communicate using IPv4 addresses as well, in simple terms. If you have any questions, just leave a comment. Okay, IPv4 address structure. An IPv4 address is 32 bits long. This is 32 bits divided into 4 octets. 1, 2, 3, 4 octets. 8 bits each. 1, 2, 3, 4, 5, 6, 7, 8. 8, 8, 8, 8. So 32, 8 bits each. This is an example of an IPv4 address. Now, the first octet, which is 1100 and then 60, total of 8 bits. The first two represents 192, and then the rest of them represents nothing, 0000. To understand this, you need to know how to convert binary to IPv4 and IPv4 to binary, which you can find on YouTube, or you can just check online, or if you can wait, then I'm happy to explain it to you on YouTube. Okay, IPv4 address components. IPv4 addresses have two parts: network portion and host portion. The network portion, basically, IPv4 addresses have two parts. Right now you can't say which part. This is an example of an IPv4 address, but you don't know which part is network and which part is host. When we say network, it's the address of the network. So this is the address. Let's say you have a home network, so this is the address of everything within your home network. And let's say your mobile phone is in that network, so your mobile phone is a host, and your mobile phone will have a separate address in this network, so let's say it could have, if this is the network address, it could maybe your device might have an address ending with 26 at the end. So this is what it means. So we don't know, because this one doesn't represent which part is network, which part is host, which one represents the whole network, which one represents if it belongs to a device. So we how do we determine that? We will find out in a second. So let's just go. We can find that out using subnet mask. So what happens is, if you go to, let's say if you go on your Windows computer, and if you just go to command prompt and then you just type IPv config, ipconfig. So we are not talking about version. So IP configurations, if you just type ipconfig, and then you can see that you will find information of the IP address, that has been assigned to you. That's the address, the host address. When we say host person, so this is the host address. And then the subnet mask represents the network address. So how do you find out which one represents the network, which one represents the host? You can find it using the subnet mask. So this one, it says 255.255.255. They're all ones of the first 3 octets. So if you don't know, you need to do your research, or you have to wait for the next video. They represent all ones, so they all belong to the network. So the first 3, we know that the first 3 bits represent the network address, the last bit represent, the last octet represents the host address. Alright, let's just go to the next section. In binary, this is the binary of the IPv address, and this is the mask address in binary. Again, if you need to learn converting to binary and binary converting to decimal, you need to learn them. Otherwise, you will not be able to do subnetting. This is learning binary is very important, because if you want to basically progress into networking, you will need to do subnetting. You will need to create VLANs, and to create subnets, and to create VLANs, and to create separate addresses, you need to know binary, because you will have to do those calculations logically in your head and try to figure out which address should be provided, which network address should be provided to each VLAN, or how you should subnet. When we say subnet, basically break down a network address to multiple addresses. You need to learn binary. CIDR, CIDR notation, classless inter-domain routing. This one also represents so there are 2 ways to find out which one represents the network address and which one represents the host portion, host addresses within an IPv4 address. So either with subnet mask, you can see that you can find it on on the command prompt if you just type ipconfig, or you can also figure out using a / class interdomain routing, CIDR notation. So if it says, most probably your home network, you will have a /24. So /24 means the first 3 octets belong to the network address, and the last octet belongs to the host part. The devices will get addresses from those part. So there are 2 ways to figure out how to figure out which one, which is network address and which is the host address, using subnet mask or CIDR, classless interdomain routing. Okay, so IPv4 classes, class A, B, C. You need to know that this is the IPv4 address range. So all the local area network devices, they will be using this private IPv4 address range. So class A range, class B. So all the IPv4 addresses within a local area network is basically an address within those range. You need to know this. You need to know the range and how you can and which address class IPv4 address to choose, and then how to do subnetting, how to basically subnet those class IPv4 classes. If it's an A, B, C, how would you? This is a /24 subnet. These are always so. This is a it's always the first three octets always belong to the network address. Here, the first two will belong to the network address, and this the first octet will belong to the network address. When we say octet, so in simple terms, let's say class A is basically all these will belong to the network. The last one belongs to the host. Class B is first two octet will belong to the network. The last two octet will belong to the host. And class A is first octet will belong to the network, and the last three octets are for the host. Okay, IPv4 addresses. So within the IPv4 addresses, you have network address. So that's the network address will represent the entire network. So your IPv4, your network address, let's say we are talking about your local area network, your network address will basically pointing out the address for everything within that network. So your network address represents all your devices within that address. Host address is a particular address assigned to an individual device. So your mobile has a separate IP address, so it's a separate host address. Your laptop has a separate IP address, so it's a separate host address. Broadcast address. Broadcast address is basically when you send a traffic to that address, all the devices will receive that traffic. Used to send data to all devices in the same network. So broadcast address means, so that's when you send a packet to that address, everyone in that network will receive that packet. Private IP address. Private IP address means these are all private IP address. This is used within the local area network. You can, like, let's say you can use those addresses. Your friends can use those addresses. Any companies, multiple companies can use those same addresses. It doesn't matter. But public IP addresses have to be separate because private IP addresses are used to communicate between the internet, between different local area network. So your whole local area network will only have one public IP address. You can have 5,000 devices in your company, and you can have 5,000 different private IP addresses, but everything will be represented using just one public IP address. This one is basically your, let's say your router is you use your router to connect to the internet. So the connection from the internet service provider to the router's port is that port has a public IP address in it, and everything that you connect from your local area network to that router will always get private IP addresses. This is not something that you can master within 10-15 minutes. So if you don't understand, you should research, you should ask questions, and everything will start making sense. Subnetting is basically when you subnetting means dividing one large network into smaller networks. So I could have explained it to you, but the video is gonna get too long. Subnetting means dividing one. So when we have, let's say we have a /24 address, you can instead of all the devices using the same address, all the devices are using the same network communication, you can separate them. So subnetting means basically separating a private IP and network address. So you have a network address, you subnet that network address, and you make more separate network addresses, and all those networks will communicate with each other separately. There will not be any conflicts between different networks. And so basically you are segmenting, you are separating all those networks within a private network, but you are separating them logically using a layer 2 switch. So basically we also basically VLANs are associated to subnetting, and you can only create VLANs using a layer 2 switch. So I hope it makes sense to you. If you don't understand, just leave your questions. Like there is an example of subnetting. Go through these. If you have any questions, just leave a comment.